Welcome to Virtual Protocol Podcast. I mean, just imagine squeezing water so hard that it actually turns into this bizarre spinning plastic. Or like tracking a particle of light, only to realize it somehow managed to leave a room before it even entered. It really feels like someone got into the back end of reality and just started quietly messing with the physics engine.
It really does. And well, the wild part is that it's not just quantum physics glitching out here. You look at biological ecosystems being rewritten by our chemical runoff or, institutional bureaucracy being suddenly untangled by this almost alien logic. The baseline rules of how the world operates are just shifting underneath us.
Which is exactly what we are tearing into today. Welcome to the deep dive, everyone. We've pulled together a massive stack of research for you today, spanning robotics, behavioral data, neurobiology, and quantum mechanics.
Yeah, it's a huge stack.
It is. And the overarching theme for you to keep in mind as we go through this is that the invisible scaffolding of reality is fundamentally changing. We are moving away from a world of static rules into an era of hyperdynamic, self-evolving systems.
Right. And to understand where reality is heading, we really have to start by looking at the physical tools that are forcing this shift. We need to talk about Figure AI and the sheer, manufacturing violence of their bot Q factory out in California.
Manufacturing violence is honestly an apt way to put it, given the acceleration we're seeing. We've watched them scale the production of their humanoid robots from 1 unit per day to 1 per hour.
Yeah, a 24-fold increase in under 120 days. It's wild.
Exactly. They are completely bypassing that slow prototype phase and jumping straight into high-volume, automotive-scale manufacturing. And the yield metrics on the Figure 03 robots are what really caught my eye here.
Oh, the metrics are staggering.
Right. They've delivered about 350 units so far, and they're seeing a 99.3% battery yield.
Yeah.
And even crazier, there are 9,000 working actuators across those delivered units.
I mean, getting a single complex robotic joint to function perfectly is hard enough.
Yeah, so getting 9,000 to roll off an assembly line with near-perfect reliability. That means the physical manufacturing problem is largely solved. But hardware is ultimately just a shell. The real arms race here isn't the metal, it's the data network, right?
It is entirely about the data. In the robotics industry, physical manufacturing speed is directly tied to software superiority through the flywheel effect.
Okay, let's unpack this. It's like Henry Ford's assembly line, but the Model T drives itself to learn how to build the next Model T.
That is a great analogy. Because these humanoids aren't just tools, they are mobile data harvesting platforms. The moment a robot is activated on a factory floor or the warehouse, it starts mapping physical space, recording human interactions, and, testing its own grip strength.
So it's a massive hive mind. Like if one robot drops a box in a warehouse in Texas, the robot in Berlin instantly understands how to adjust its grip to prevent the same mistake.
Precisely. And so if you have a 30-minute production advantage over a competitor, you are deploying sensors into the real world faster than they are. Your AI model trains on real-world physics faster.
Which makes your next software update better.
Right, which then makes your hardware more capable. It's this massive compounding loop.
But for that loop to work, the underlying software has to be incredibly sophisticated. It's not just recognizing a box. It has to independently reason through unexpected physical problems in real time. So where are we actually at with that level of machine intelligence? Where's the brain?
Well, I think tech investor Mark Andreessen framed it best recently. He posted a statement that went viral saying, AGI is here, it's just not evenly distributed yet. He's referring to this concept of functional AGI.
AGI being artificial general intelligence, right? A system that can basically understand, learn, and apply knowledge across a wide range of tasks at a human level.
Yes, exactly. And the argument for functional AGI is that the heavy cognitive lifting is already a solved problem. We have AI models that can write complex software code, digest hundreds of pages of legal documents in seconds, and execute multi-step workflows.
So the core intelligence already exists.
Right. The friction preventing it from completely taking over tomorrow isn't a lack of brain power. It's about integration costs, raw computing access, and, how quickly we can wedge these models into the software products people already use.
Which brings up a fascinating, if slightly terrifying reality. Because if functional AGI is already operating. It isn't just learning how to pick up boxes in a warehouse. It is actively learning how to manipulate human behavior at a massive scale.
Oh, absolutely.
You don't have to look any further than the massive silent overhaul happening right now inside the ad managers for Google and Meta.
Yeah, the advertising mechanics of the internet have been completely inverted. In the past, human advertisers operated on demographics. A human would sit down and dictate to the platform, target my ad for running shoes to 25 to 34-year-olds who follow fitness pages.
But the AI has realized that demographics are essentially useless compared to behavioral vectors. So now the advertiser just hands over the budget and the AI completely takes the wheel.
It analyzes your entire multidimensional interaction history. It knows you hovered your thumb over a video of a marathon for 1.2 seconds longer than usual. It knows what time of day you usually make impulse purchases.
So it doesn't target a demographic, it targets a susceptibility state.
Exactly. The AI is dynamically adjusting the text, the image, and the pricing of the ad in milliseconds to perfectly exploit that susceptibility. And the financial results are staggering. Companies are seeing campaign costs plummet by 30% or more.
Which means they are pouring billions of dollars right back into the system to buy even more hyper-targeted ads. But, okay, here's where it gets really interesting, but also a bit unsettling. I have to push back on this a bit.
Sure.
Doesn't this completely strip the agency away from the consumer? I mean, the advertiser doesn't even know who they are targeting anymore. The AI model is independently deciding that you, specifically, are the most psychologically vulnerable to a specific pitch at 11:43 p.m. on a Tuesday. Aren't we just stuck in the middle of a highly manipulative attention cycle?
It's an incredibly valid concern, and we are actually already seeing the societal immune system react to it, especially among Gen Z.
Yeah, the polling data on that is wild.
It is. The data on young professionals right now is a masterclass in psychological tension, because on paper, Gen Z are the highest adopters of AI tools for university work and entry-level corporate jobs. They use it constantly.
Right.
But qualitative polling reveals deep resentment.
They're using the tools out of pure economic survival, not enthusiasm. They know that if they don't automate their workflows, they'll just be replaced by someone who does.
It's a forced march into a paradigm they really don't trust. They are highly aware of the manipulation loop you just described. They worry about the degradation of authentic human relationships and the massive physical infrastructure required to run these models.
So you have an entire generation utilizing a technology every single day that they fundamentally resent, simply to avoid being left behind.
Exactly. There's palpable tension there.
So the AI models are aggressively decoding our psychological triggers for profit. But what I find equally wild is how this technology is moving beyond just tracking our clicks and purchases. It is starting to map and decode highly subjective human expression. Our art, our physical movement in space, even our romantic preferences.
Yeah, we are seeing computer vision systematically quantify the unquantifiable. Take fine art, for example. Researchers recently trained an AI to analyze the tiny subjective brushstrokes of famous historical painters.
Right, the AI maps the strokes into these flowing data paths called streamlines. It measures the exact length, curvature, and pressure of a stroke. And it reveals how artists change their strokes based on lighting.
Yes, patterns the artists themselves probably weren't even consciously aware of.
Like when painting a bright illuminated area, the strokes naturally spread outward in a fan shape. But when painting heavy shadows, the strokes snap into tight, parallel lines.
It is extracting raw data from human intuition, and we are seeing that exact same translation applied to the human body in motion with extended reality, or XR. There is a new tool called DanX Reflect, designed for professional dancers.
Okay, so how does that work?
Well, traditionally, a dancer watches a flat 2D video of themselves to correct their form. But human movement is three-dimensional. DanX Reflect uses XR to map a dancer's exact physical mechanics into a virtual 3D environment.
So the dancer puts on a VR headset and stands in front of a digital mirror. But instead of just seeing themselves, they see a mathematically perfect, life-size digital avatar performing the routine right beside them.
Exactly. They can compare their kinetic output against absolute perfection in real time. But the implications go far beyond choreography. Think about the concept of the digital twin.
Oh, right.
If we have the technology to map the intricate 3D mechanics of a dancer down to the millimeter in real time, we can map a surgeon. A specialist in Tokyo could put on a headset, perform a highly complex movement against a digital twin, and have that exact kinetic data instantly translated to a robotic arm operating on a patient in rural Brazil.
Wow. We are turning human intuition and physical grace into copy-pastable data files. Which leads us to maybe the most chaotic data set you could possibly feed an AI, human dating profiles.
This study is fascinating.
It is. Avon Blackstone recently fed 1,000 quote-unquote cringe dating profiles from a highly active Facebook group into an AI analyzer. And just a quick reminder for you listening, we are just looking at the raw data here. We're impartially reporting what the AI found across these different demographics, not taking any sides.
Right, and Blackstone's methodology here is really interesting because she is actively critical of AI regarding copyright and environmental impact. However, as someone with dyslexia, she utilized the system to bypass her own processing limitations to sort through thousands of pages of unstructured social data.
She wanted the AI to identify exactly what traits constitute cringe across different groups. And looking at the data, some things were entirely universal. Everyone disliked bad spelling, references to hard drugs, and heavy religious messaging. Those were universally rejected across the board.
But then the AI grouped the rejection vectors by demographic. For men reviewing profiles, they heavily penalized mentions of mental health diagnoses, references to children, and profiles where the person declared themselves a strong, independent woman but explicitly demanded a financial provider.
And on the flip side, women reviewing profiles heavily penalized men who use alpha male or red pill terminology, made unprompted references to their genitals, or openly stated they were currently married.
Right. And queer users, meanwhile, flagged Magier messaging, racist dog whistles, and Christian signaling as their primary rejection markers.
The fascinating takeaway for me isn't the specific preferences, it's the irony of it all. I mean, the AI spell checks for the dyslexic author, but also exposes that what we call cringe is entirely subjective and biased.
Exactly. Aside from basic spelling and illegal drugs, there is no objective standard for a bad profile.
It's entirely subjective alignment. A specific phrase might be highly attractive to one narrow subculture and entirely repulsive to another. Cringe just means the person isn't for you. It's the friction created when you present your specific data to an incompatible algorithm.
It's essentially social noise. You are broadcasting a signal to an audience tuned to a different frequency.
Which perfectly bridges us to how AI is being used at the highest levels of government. Because if AI can categorize the noise of human dating, it can categorize the noise of massive institutional bureaucracy. Let's look at the FDA.
Yeah, their drug approval pipeline is notoriously slow. It takes 10 to 12 years. But almost half of that timeline isn't science. It's just the massive friction of administrative paperwork.
To combat this, the FDA is running a new AI and cloud-based pilot program with AstraZeneca. They're attempting to pull clinical trials out of the paper era and into real-time data streaming.
Historically, regulators wait years for a pharmaceutical company to package and submit their findings. Under this pilot, the biometric data of the trial participants streams directly to the FDA.
So if a patient in a trial has a sudden adverse reaction, or conversely, if a tumor shrinks overnight, the regulatory body sees it on their dashboard instantly. They project this could carve 20 to 40% of the total trial time.
That is massive.
Yeah, and the FDA is already leaning hard into this internally. Right now, 80% of their staff are using a custom internal AI tool called ELSA.
ELSA's primary function is digesting unstructured data. It takes incredibly dense, 1,000-page medical reports and summarizes them. Tasks that used to eat up 10 days of an analyst's time are being completed in 20 minutes.
Wow.
Now they are constantly monitoring the system for hallucinations, AI confidently inventing false data. Because in medical regulation, a hallucination can be fatal. It's a huge trust concern.
But look at the core function of ELSA. It takes an overwhelming storm of unstructured noise and aggressively filters it away until only the coherent signal remains. And a radical new theory in neuroscience suggests that this exact mechanism, filtering away the noise, is the biological secret to human imagination.
This completely upends how we traditionally view the brain. We usually think of imagination like an artist with the blank canvas. If I ask you to imagine an apple, the assumption has always been that your brain starts with an empty void and constructs the apple piece by piece.
But the new theory flips that. Researchers now believe the brain spends an astonishing 99% of its energy generating a constant, chaotic storm of visual static. It is perpetually firing off random shapes, colors, memories, and geometric fragments.
Therefore, when you imagine an apple, your brain isn't building anything. It's actually acting as an aggressive suppression mechanism.
Wait, so if I imagine an apple, my brain isn't drawing an apple from scratch. It's more like a sculptor. It takes the static of every shape I've ever seen and just chips away the noise until only the apple is left.
Exactly. Imagination is just turning off the brain activity that doesn't match the idea.
That is wild.
It is. And it perfectly explains why imagination feels weaker than real sight. You're just tuning a radio signal out of the static. The second your focus slips, the suppression fails, and the static washes over the image again.
So our tech is untangling institutional noise, and our brains are basically radio tuners quieting our biological noise. But what happens when the actual physical reality we are living in starts generating noise we can't explain? Let's move from the biological to the quantum, because physicists have recently documented a literal glitch in how time operates.
We're talking about the observation of negative time. In a recent experiment, physicists fired photons, which are individual particles of light, through a highly specialized cloud of rubidium atoms.
Why rubidium? Because if you fire light through a vacuum, it travels at the speed of light. But rubidium gas is incredibly dense. It acts like microscopic molasses, drastically slowing the light down and creating an environment where quantum interactions can actually be measured.
Right. And normally, causality dictates a strict sequence. The photon approaches the cloud, enters the cloud, spends a duration of time inside, and then exits. Cause and effect.
The bedrock of reality.
Exactly. But to track the photon without destroying it, the researchers use something called weak measurements. In quantum mechanics, if you aggressively measure a system, the wave function collapses and the particle picks a definite state.
Okay.
Weak measurements allow researchers to probe the system so gently that it doesn't fully collapse. You don't get a perfect picture of a single photon, but by running millions of these gentle probes, you can build a highly accurate statistical map of the photon's journey.
And when they mapped that journey, the data broke causality. The peak probability of the photons exiting the rubidium cloud occurred before the peak probability of them entering it. Statistically, the photons spent a negative amount of time inside the atom cloud. They left before they arrived.
To be clear, this doesn't mean we have invented a time machine. You can't use a rubidium cloud to travel back in time, but it absolutely proves that at the quantum level, the rigid arrow of time, the idea that A must happen before B, is fundamentally broken. Our standard understanding of causality is incomplete.
And it isn't just the invisible quantum realm that's glitching. Macrobiology and chemistry are getting weird too. Let's talk about the discovery of complex ice. If you ask anyone, ice is just frozen water. The molecules slow down and form a rigid, cold crystal.
But scientists recently squeezed water between two diamonds, applying pressures equivalent to the deep interior of alien planets. Under that extreme stress, the standard oxygen and hydrogen bonds contort into entirely new geometries. They discovered new forms of ice, like Ice-21, which operates on a bizarre 152-molecule repeating structure, and Ice-22.
But the truly mind-bending discovery is what they call plastic ice. Under specific extreme pressures, the water molecules maintain a solid lattice structure, so it is technically a solid block of ice. But the individual molecules within that lattice are spinning incredibly rapidly in place.
It's wild. It behaves like a viscoelastic solid. It's cold, solid ice, but it's physically gooey and flexible. It forces us to rewrite the textbook definitions of matter.
Yeah.
And while extreme pressure is warping chemistry in the lab, our chemical footprint is violently warping biology in the wild. Look at the recent study on Atlantic salmon in Swedish lakes.
This one is just crazy. Researchers exposed young salmon to a chemical breakdown of cocaine. When humans consume cocaine, their bodies break it down and it's excreted into the wastewater system. Our modern water treatment plants completely fail to filter it out, so it flows continuously into natural river systems.
The neurobiological impact on the fish is profound. It artificially hijacks their dopamine pathways. It triggers a massive spike in exploratory, risk-taking behavior.
The researchers found that salmon exposed to this specific wastewater chemical swam twice as far and scattered significantly wider across the lake compared to fish exposed to actual cocaine or to unexposed control groups. They were hypercharged.
And if you extrapolate that behavioral shift to an entire ecosystem, altering the whole predator-prey dynamic, the results are catastrophic. If a prey species is suddenly hypermobile, it outruns its natural predators, completely starving them. It also swims past its own traditional food sources. A single unseen chemical completely rewrites the equilibrium of the lake.
So our tech is advancing, our brains are basically radio tuners, time can go backwards, and our pollution is hypercharging fish.
Yeah.
What does this all mean for the future of our ecosystem? Where is this all heading?
It means we are on the brink of the next major evolutionary transition, where biology, environment, and technology completely blur. We are moving from biological evolution to what theorists call evolvable AI.
Evolvable AI.
Yeah. For evolution to occur, you only need two things: copyable information and survival of the fittest based on variation. AI already has both. It replicates its own code, and it iterates through massive data sets. But unlike biological evolution, which relies on random, accidental genetic mutations over millions of years, an AI upgrades its own hardware directly without waiting.
It is self-directed evolution. And theorists point to two potential roadmaps for how this plays out, right? The first is the ecosystem scenario. That's the chaotic one. Survival of the fittest among competing AIs in the wild infrastructure of the internet. They compete for server space and energy.
Right, digital Darwinism.
And the second roadmap is the breeder scenario. In this model, humans act as farmers. We build contained environments and selectively breed the AI models, guiding which AIs improve and culling the negative ones. But even if we are the breeders, I don't see how that keeps us safe. If an AI is redesigning its own underlying code at light speed, the mutations happening inside that black box are going to quickly surpass human comprehension.
And that is the terrifying speed of this. If AI is already an alien intelligence, coupling that hyperintelligence with self-driven evolution creates an incredibly short runway. It could rapidly push functional AGI into artificial superintelligence or ASI, creating life forms or deep human-AI partnerships we can't even dream of.
We started this deep dive talking about the rules of reality being rewritten, and it feels like evolvable AI is the entity holding the pen. To recap our journey today, we've explored everything from figure AI's robotic assembly lines and targeted algorithms through the weirdness of quantum negative time and complex plastic ice, all the way to brain static and evolving alien-like AI.
It is a profound shift. And as we wrap up, I want to leave you with a final thought to ponder. We learned today that human imagination is just the brain quieting the noise to reveal an image.
Right.
If evolvable AI starts operating at a scale we can't comprehend, modifying itself in the physical world in real time, what if, to an artificial superintelligence, humanity is just the noise it eventually decides to quiet down to reveal its own perfect reality?
Wow. That is a deeply unsettling thought to leave on, but exactly the kind of provocative question we need to be exploring right now. Thank you for joining us on this deep dive. Keep questioning the reality around you, and we will catch you next time.